Dear students, in part 14, I will discuss some more questions of trigonometric functions. So let us start with this important question. Prove that tan 70 degree is equal to tan 20 degree plus 2 tan 50 degree. Now let us transpose this value to the left hand side. We can write tan 70 degree minus tan 20 degree is equal to 2 tan 50 degree. Now you know the formula of tan A minus B. Tan A minus B is equal to tan A minus tan B upon 1 plus tan A into tan B. You know this formula, tan of A minus B is equal to tan A minus tan B upon 1 plus tan A into tan B. Now from the question, it is clear that this side, left hand side, is in the form of tan A minus tan B. So I can write this tan A minus tan B is equal to tan A minus B multiplied with tan of A minus B multiplied with 1 plus tan A into tan B. Now in this side, if I take angle A equal to 70 degree and B equal to 20 degree, let A be equal to 70 degree, put angle A equal to 70 degree and B is equal to 20 degree. Then tan 70 degree minus tan 20 degree is equal to, here we get the difference of these angles 70 minus 20, 50, which is here in the right hand side. So tan 50 degree into 1 plus tan 70 degree into tan 20 degree. 70 degree and 20 degree angles are complementary angles, means their sum is 90 degree. So I can change this, either I can change tan 70 or tan 20. So this implies that tan 70 degree minus tan 20 degree is equal to tan 50 degree into 1 plus, and here I can either change this tan 20 or tan 70. Tan 70 is equal to cot tan theta is equal to cot 90 minus theta. We know that tan theta is equal to cot 90 degree minus theta. So into tan 20 degree. Now this is equal to tan 50 degree into 1 plus cot 90 minus 70 is cot 20. Cot 20 degree into tan 20 degree. This gives us tan 70 degree minus tan 20 degree is equal to tan 50 degree into 1 plus this cot 20. Cot 20 you can write this as 1 upon tan 20. Cot theta is equal to 1 upon tan theta. So 1 upon tan 20 degree into tan 20 degree. This tan 20 and tan 20 cancelled. This implies that tan 70 degree is minus tan 20 degree is equal to tan 50 degree into 1 plus 1. 1 plus 1, which is equal to 2 tan 50 degree. And this was to be proved that tan 70 degree minus tan 20 degree is equal to 2 tan 50 degree. Students, since in the questions we can transpose the values from one side to the other, there is no problem. So according to the convenience in the question, we can transpose right hand side to left hand side or left hand side to right hand side. So in this question I have transposed this tan 20 degree to the other side. So tan 70 minus tan 20 is equal to 2 tan 50 degree. So the solution of this question is complete. Students, next question. Prove that sine raised to the power 4 pi by 8, sine 4 3 pi by 8, sine raised to the power 4 5 pi by 8, sine raised to the power 4 7 pi by 8 is equal to 3 upon 2. So let us solve this question. Sine 4 pi by 8 plus sine 4 3 pi by 8. By 4 I mean to say the raised to the power 4. Plus, now this 5 pi upon 8 I can write this is equal to sine 4 pi minus 3 pi upon 8. Because 5 pi you can write as 8 pi minus 3 pi upon 8, which on simplification gives you pi minus 3 pi upon 8. What I am doing here, I want to convert this 5 pi by upon 8 into 3 pi by upon 8, and 7 pi upon 8 is 8 pi minus pi, that is pi minus pi upon 8 plus sine 4 pi minus pi upon 8. And you know sine pi minus theta is equal to sine theta, so we can write this is equal to sine 4 pi upon 8 sine raised to the power 4 3 pi upon 8 plus sine raised to the power 4 3 pi upon 8 plus sine raised to the power 4 pi upon 8. This pi upon 8 and pi upon 8 twice of sine 4 pi upon 8 plus twice of sine 4 3 pi upon 8. But you don't know the value of pi upon 8. You know the value of pi upon 4, which is the double of pi upon 8. If we double pi upon 8, so we will take this question to the angle pi upon 4. How? 2 into 2 sine 4 pi upon 8 plus sine 4 3 pi upon 8. Now, you know sine square theta, sine square theta is equal to 1 minus cos 2 theta upon 2. You are familiar with this identity. Cos 2 theta is equal to 1 minus 2 sine square theta, or sine square theta is equal to 1 minus cos 2 theta upon 2. By using this identity, we can convert this pi by 8 angle to pi by 4 angle. So I can write this is equal to 2 into 1 minus cos twice of pi upon 8, that is pi upon 4 upon 2. This is sine square theta, but we have sine raised to the power 4, its square. Because this 1 minus cos pi upon 4, 1 minus cos pi upon 4 upon 2 is equal to sine square pi upon 8. Similarly here, sine square 3 pi upon 8, I can write 1 minus cos twice of this angle. Twice of this angle 3 pi upon 8 is cos 3 pi upon 4 upon 2 its square. Now this upon 2 its square will be 4, upon 2 its square will be 4, so I can take upon 4 common, So I can write this is equal to 2 upon 4, and here 1 minus cos pi upon 4 its square plus 1 minus cos 3 pi upon 4 its square. Bracket close. This 2 1 is 2, 2 2 is 4, 1 by 2. Now, uh, 1 minus cos pi upon 4. You know the value of cos 45. Cos 45 is equal to 1 upon root 2. And cos 3 pi upon 4 is equal to cos pi minus pi upon 4. And this is equal to, in the second quadrant, cos is negative, minus cos pi upon 4, which is equal to minus 1 by root 2. So here I can write 1 upon root 2, 1 minus 1 upon root 2 square, plus here the value is minus 1 upon root 2, and because of this minus sign it becomes plus. So 1 plus 1 upon root 2 square. Now take LCM, 1 by 2. Here I can write root 2 minus 1 upon root 2 by taking the LCM. LCM of, here we have 1 and here root 2, so LCM is root 2, and on simplification we get root 2 minus 1 upon root 2 plus here root 2 plus 1 upon root 2. And you know the root 2 square is 2, so I can take this 1 by 2 into this root 2 square is 2, so 1 by 2 out, and here I have root 2 minus 1 square plus root 2 plus 1 square, which is equal to 1 upon 4 into a, using the formula of a minus b. A minus b whole square is equal to a square plus b square minus 2ab. So if I use that formula, this is root 2 square is 2 plus 1 minus 2 root 2. And here I have 2 plus 1, root 2 square is 2, 1 square is 1 plus 2 root 2. This 2 root 2 and 2 root 2 get cancelled. 2 plus 1 is 3, 3 plus 3 is 6. 6 upon 4. 6 upon 4 is equal to 3 upon 2. Students, we have got the right hand side. We need to prove that the value of these 4 powers, sum of these 4 powers is equal to 3 by 2. So the question solution of this question is complete. Next question, question number 3. Cos alpha plus cos beta is 1 upon 3. Sin alpha plus sin beta is 1 upon 4. Prove that cos alpha minus beta by 2 is equal to plus minus 5 upon 24. So what we need here? Cos of alpha minus beta by 2. Cos of alpha minus beta by 2 is obtained if we get cos alpha minus beta. Then we can calculate cos alpha minus beta by 2. Here, if I square and add, then I will be having cos alpha, cos beta, sin alpha and sin beta there. And if you have cos alpha, cos beta and sin alpha, sin beta, then you can write the formula for cos of alpha plus beta or cos of alpha minus beta. So squaring and adding. So if I square and add, then cos alpha plus cos beta square plus sin alpha plus sin beta its square is equal to 1 upon 3 square plus 1 upon 4 square. Now you know a plus b whole square is equal to a square plus b square plus 2ab. Sin alpha plus sin beta square, again this is equal to sin square alpha plus sin square beta plus sin alpha into sin beta, which is equal to 1 upon 9 plus 1 upon 16. And on taking the LCM, we get LCM is 144, and 16 plus 9, which is equal to 25 upon 144. Now why I have squared and added? Because the identity cos square alpha plus sin square alpha can be used here. And the second, we are having cos alpha cos beta and sin alpha sin beta, which gives us the formula for cos of alpha minus beta. So both we are successful in getting this. That's why we have squared and added. Now this cos square alpha added with sin square alpha, this is 1. This cos square beta added with this sin square beta, again 1, so 1 plus 1, and then plus 2 cos alpha cos beta is equal to 25 upon 144. 2 cos alpha cos plus uh, here we have 2 sin alpha sin beta plus 2 sin alpha sin beta. So this gives 2 plus 2 is common, and then cos alpha cos beta plus sin alpha sin beta, this is equal to 25 upon 144. If I take 2 common, then 1 plus, and this is the formula for cos of alpha minus beta. Cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. This is equal to 25 upon 144. Now 1 plus cos alpha minus beta, you know, 1 plus cos A is equal to 2 cos square A by 2. So I can write 2 into 2 cos square alpha minus beta by 2. Because you know that 1 plus cos A is equal to 2 cos square A by 2. Or cos square A by 2 is equal to 1 plus cos A upon 2. So using that formula, 1 plus cos of A is equal to 2 cos square A upon 2. This is equal to 25 upon 144. Now 2 into 2 is 4. 4 cos square alpha minus beta by 2 is equal to 25 upon 144. Or you can say that the value of cos square alpha minus beta upon 2 is equal to 25 upon 144 into 4. This 4 which was in the multiplication, it will come in the denominator. Now we can find the value of cos alpha minus beta by 2 is equal to plus minus. If we take the square root of 25, it is 5, and 144 is 12, 4 is 2, so plus minus 5 upon 24. और यही आपको सॉल्व करना था, that cos of alpha minus beta by 2 is equal to plus minus 5 upon 24. Student, next question. If tan theta by 2 is equal to under root 1 minus e upon 1 plus e tan phi upon 2, prove that cos phi is equal to cos theta minus e upon 1 minus e cos theta. Here you want to find the value of cos phi, and in the right hand side you are having cos theta. So let us first find the value of tan phi upon 2 from the given from this given expression. Tan phi upon 2 is equal to, this will be multiplied here, root 1 plus e, and this will go in the denominator 1 minus e, and tan theta upon 2. So we have got the value of here tan phi upon 2 in terms of e and tan theta upon 2. Now you know the identity that cos phi is equal to 1 minus tan square phi upon 2 upon 1 plus tan square phi upon 2. So you know cos 2a is equal to 1 minus tan square a upon 1 plus tan square a, or cos a is equal to 1 minus tan square a by 2 upon 1 plus tan square a by 2. Now we can put the value here. This is equal to 1 minus the value of tan phi upon 2 is this value, and we will square it, so 1 plus e upon 1 minus e into tan square phi theta upon 2, and in the denominator 1 plus, and the square of this value is 1 plus e upon 1 minus e, and the square of tan theta by 2 is tan square theta by 2. Now taking the LCM in the numerator and the denominator, so we can write this is equal to 1 minus e minus 1 plus e into tan square theta by 2 and whole upon 1 minus e in the numerator. Similarly, in the denominator, taking the LCM as 1 minus e, if you take the LCM as 1 minus e, then 1 dividing 1 minus e by 1 and multiplying, you get 1 minus e plus 1 plus e into tan square theta by 2. This 1 minus e and 1 minus e is cancelled. Now, this expression is equal to, if we rearrange the terms, then 1 minus e, and here we have minus tan square theta by 2, and plus minus is minus e tan square theta by 2 upon, in the denominator we have 1 minus e plus tan square theta by 2 plus e tan square theta by 2. Now this e we will keep it separate. Then I can write this is equal to 1 minus tan square theta by 2, and from these this e and this minus e tan, taking minus sign common, 1 plus tan square theta by 2. Solving, keeping these two terms together and these two together. Similarly, in the denominator we have 1 plus tan square theta by 2, and here if I take minus e common from these two terms, if I take minus e common, then I get 1 minus tan square theta by 2. Now to make the formula, this formula 1 minus tan square theta by 2 upon 1 plus tan square theta by 2 is equal to cos theta. Divide numerator and get rid of this here with e, and to get rid of this with e, minus e is here. So dividing both numerator and denominator, dividing numerator and denominator by 1 plus tan square theta by 2. So if we divide by 1 plus tan square theta by 2, then this formula can be applied. So if I divide in the numerator, then I get, if the first term is divided by 1 plus tan square theta by 2, then I get 1 minus tan square theta by 2 upon 1 plus tan square theta by 2. And here if I divide by 1 plus tan square theta by 2, it is left with e only. Similarly, in the denominator, if I divide by 1 plus tan square theta by 2, if you have an expression a upon b, if you divide a by m and b by m, it is not going to affect the result. So here if I divide by 1 plus tan square by 1 and minus e into 1 minus tan square theta by 2 divided by 1 plus tan square theta by 2. And you know this formula 1 minus tan square theta by 2 upon 1 plus tan square theta by 2 is equal to cos theta. So I can write this is equal to cos theta minus e upon 1 minus e cos theta. And you know in the right hand side what we need to prove that cos phi is equal to cos theta minus e upon 1 minus e cos theta. We have got the desired result. So the solution of this question is complete. I think you have understood this solution. Yes, students, last question of this part number 14. If a cos 2x plus b sin 2x is equal to c, has alpha comma beta as its roots, then prove that tan alpha plus beta is equal to b upon a. Now a cos 2x plus b sin 2x is equal to c. Students, can we convert this cos and sin into tan? Yes. You know cos 2x is equal to 1 minus tan square x upon 1 plus tan square x. So making this equation quadratic in tan x, a into 1 minus tan square x upon 1 plus tan square x plus b into 2 tan x upon 1 plus tan square x is equal to c. Now you can take the LCM. LCM is 1 plus tan square x. So if I take the LCM as 1 plus tan square x, then here I get a into 1 minus tan square x plus 2b tan x is equal to c. Now multiplying by a here, a minus a tan square x plus 2b tan x is equal to c into 1 plus tan square x, that is c plus c tan square x, c plus c tan square x. Now rearranging the terms. If I rearrange the terms means bringing these values here, I can write a minus a tan square x minus c tan square x plus 2b tan x minus c is equal to 0. Now a minus a tan square x and minus c tan square x, I can take minus tan square x as common. So minus a plus c into tan square x plus 2b tan x minus c and minus c and here we have a. So plus a is equal to 0. Now if I take minus sign common from the whole expression in the left hand side, then I can write a plus c tan square x minus 2b tan x plus c minus a is equal to 0. And you can see this is a quadratic equation in tan x. Roots of this equation are alpha and beta, so roots of this quadratic equation in 10x are since alpha comma beta are roots of given trigonometric equation, therefore tan alpha comma tan beta are roots of equation first. This is our equation first. Its roots are tan alpha and tan beta. Uh, two values of tan x. Now this is a quadratic equation. From here we can find the value of, because we need the value of tan alpha plus beta. So for that we need the value of tan alpha plus tan beta and tan alpha into tan beta. So here from here we can find the value of tan alpha, sum of the roots tan alpha plus tan beta is equal to minus coefficient of this minus 2b, that is minus 2b upon a plus c. So the value is equal to 2b upon a plus c, value of tan alpha plus tan beta. Similarly, you know, in a quadratic equation ax square plus bx plus c equal to 0, if the roots are alpha and beta, then alpha plus beta is equal to minus b upon a. The same I have done here. And alpha into beta, that is tan alpha into tan beta, is equal to c upon a, constant value. Constant term is c minus a. C minus a upon c plus a. Now we have got the value of tan alpha plus tan beta and tan alpha into tan beta. So now in this expression, tan alpha plus beta, we can use these values. So tan alpha plus beta, you know, this is equal to tan alpha plus tan beta upon 1 minus tan alpha into tan beta. Putting these values here, if I put the value of tan alpha plus tan beta, which is 2b upon a plus c, and in the denominator, the value of tan alpha into tan beta is c minus a upon c plus a, 1 minus c minus a upon c plus a. Now in the denominator, take the LCM. If I take the LCM in the denominator, then this tan alpha plus beta is equal to 2b upon a plus c divided by c plus a minus c plus a upon c plus a. Taking the LCM in the denominator, the LCM in the denominator is c plus a. So c plus a minus c plus a upon c plus a. This c plus a and c plus a is cancelled. C and c is also cancelled. So the value is equal to 2b upon 2a. Value of tan alpha plus beta is equal to 2, or this is equal to b upon a. और आपको यही वैल्यू लानी थी tan alpha plus beta is equal to b upon a. So we have succeeded in solving the question that tan alpha plus beta is equal to b upon a. So with this question, I conclude this part of trigonometry. Thank you, students.